So what we're going to look at in this lesson is solving and graphing radical equations by determining the intercepts and solving a function both graphically and algebraically. Before we do though, let's recall solving an radical equation. And we've done this in previous courses. Remember, what we want to do is get the radical by itself by just moving whatever is not a radical to the other side, and we'll get root x plus 1 equals 7. And then at this point, now we can square both sides. And when we square both sides, we'll get rid of that square root, that radical, and get x plus 1 equals 49. Moving the 1 to the other side, we'll get x equals 48. And what we always have to do, though, with radicals, when we start squaring something, there's a possibility that that is not the solution. We always have to check to make sure that we have the correct solution. And the check is pretty straightforward. We just put our answer of x equals 48 into the original equation and see what we get. And you can probably see already, if we do 48 plus 1 minus 7, the question is, does that equal 0? And square root of 49 minus 7, does it equal 0? And of course we get 7 minus 7, which does equal 0. So then we could say that x definitely does equal 48. And this technique of solving for the square root, or solving for the radical first, is the same process regardless of the root. We still do the exact same thing. First, isolate for the radical. Get the radical by itself. Then, raise both sides to the power of the index. If it's squared, we square both sides. If it's cubic, we take the cube root, vice versa. Then, raise both sides to the power of the index. If it's a square root, we square both sides. If it's cube root, we cube both sides. This is the same process. Once we get rid of that radical, you solve for the unknown. And of course, we always check in the original equation. And we check because we might get these extraneous roots, and extraneous is really just the extra roots. We may get solutions that are not correct. So we always have to check your solutions. Now, these rules can also be used to find intercepts. If we want to find the x-intercepts, we just set y equal to 0 and follow these steps. If we want to find the y-intercept, we just set x equal to 0 and then solve, which is usually pretty easy to do. Let's try this then on this radical. It looks a little unpretty here. F of x equals the root of 10 minus 3x plus x minus 2, and we want to find the x and y intercept. Well, let's start with the y-intercept. And the y-intercept is often easy because all we have to do is set x equal to 0. So we're going to take our f of 0, put 0 into our function, and see what we get. Well, we just get 10 minus 3 times 0 plus 0 minus 2, which is pretty easy to see. We get root 10 minus 2. And we could just leave it in that form, root 10 minus 2. Now, often what we do, though, is we write the number first, and we would say it's negative 2 plus root 10. There is the y-intercept. If we were writing that as an ordered pair, our y-intercept would be at 0, and it looks a little weird, but if we needed to graph it, we'd put it in a calculator and find the decimal. 0 and negative 2 plus root 10. So finding the y-intercept is actually pretty easy when we have a radical equation. We just set x equal to 0. Well, what if we wanted to find the x-intercept? So to find the x-intercept, we start in a very similar way, but the x-intercept this time will occur when y equals 0. So we're going to take our whole f of x and set it equal to 0. That just allows us to take the entire equation or function, and now we have to solve for x. Just taking the f of x, changing it to 0, Well, just like we did before, we want to get the inequality by itself. So we're going to take everything that's not an inequality to the other side. That's going to leave us with 2 minus x is equal to root 10 minus 3x. Now, because this is a square root, now we want to take both sides and raise them to the index. In this case, square both sides. That's nice for the radical because it just becomes 10 minus 3x. And on the other side, we have 2 minus x and 2 minus x. Remember, squaring a binomial means we multiply it by itself. If we were to expand this binomial out, we would get 4 minus 4x plus x squared. And of course, we still have 10 minus 3x. And now we're down to a quadratic. And this quadratic we have to solve. And remember, to solve a quadratic, we need to bring everything to the same side. So we'll get x squared minus x minus 6 is equal to 0. Just moving all of those values to the same side. And we have a quadratic that we can now factor. It becomes x minus 3, x plus 2 is equal to 0. And in the end, we get 2x solutions of 3 and negative 2. Now, what we have to be careful about, though, is that these are the only potential solutions. What we must always do is now take our solutions and check the solution. So let's do the check. And we're going to check here if x equals negative 3. So to do the check, all we have to do is take our original function and put in 3. And if we get 0, then we know it's a intercept. Well, we just go to our root and replace the x's with 3, like so. All of our x's became 3, and square root of 10 minus 9 becomes root 1 plus 3 minus 2, which of course is 4 minus 2, which equals 2. And this is not 0. If it's not 0, it's not an intercept. So what we have to do is actually take this value of x equals 3 and throw it away. It's an extraneous root, an extra root. Now that doesn't mean the other one's going to work for sure, so we also have to check the other solution. So let's check x equals negative 2. Same thing we did before. We just put it into our function, and we want it to be 0 to be an intercept. So we get 10 minus 3 times negative 2 minus 2 minus 2, which becomes the square root of 16 minus 4, which is 4 minus 4, and you can probably see already, which equals 0. So that tells us that x equals 2 is our only solution to this radical function. We have to throw away the extraneous roots. X equals 2 would be the intercept, and if we were asked to do it as an ordered pair, we would get negative 2 and 0. Well, when we're asked to solve a radical equation, what we're trying to do is we're actually trying to find the x-intercepts. The solutions or the roots or the intercepts all means the same thing. Solving this radical equation is finding the x-intercept or finding the roots of this radical. And we can do this algebraically. Anytime we want to find the x-intercept, we just set y equal to 0. That's going to find us the place that the radical crosses the y-axis, the roots. So we'll just take f of x and make it equal to 0. And really, an equation like this is pretty easy to solve algebraically. We just have the square root of 3x minus 2 minus 2. Bring the 2 over, solve for that radical, isolate it, get it by itself. Once we get to this place, now, because it's a square root, we want to square both sides. which gives us 4 equals 3x minus 2. And solving for x here, pretty easy. Move that 2 over. We'll get 3x. Divide both sides by 3. And we get our solution of x equals 2. Now remember, that's our potential solution. We must check this. And we must always do this with a radical. Check it in the original function. So we're going to put 2 in to our original function. And when we put 2 in there, we'll get 3 times 2 minus 2. And that minus 2 is part of the original function. Remember, we're hoping that this equals 0. Well, 2 times 3 is 6 minus 2 is root 4 minus 2. And you can probably see already we're going to get 2 minus 2, which equals 0. So then we can definitely say that our solution is x equals 2. And algebraically is one way that we can always solve these radical equations. But it's not the only way. We could also solve these radicals by graphing. We could graphically solve these. So all we'd have to do is first create the graph, and from the graph, find where it crosses the y-axis. So take a second now and graph this radical function using the skills we learned in the last section. So remember, to graph this radical equation, we want to find the starting point, and that's what makes the radical, in this case, is a square root equal to 0 at x equals 2/3. The radical will be 0, and of course the f of x, or the y solution, then will be -2. So on the graph, we would be somewhere approximately down here. There's our first point. And now we just want to choose points that make the math easy. If we put 1 in there, we are going to get -1. If we put 2 in there, we'll get 0. If we put 6 in there, we'll get 3. And that'll give us enough points to sketch the radical and get an idea of what it looks like. Now, once we have the picture, the solution, or the x-intercept, is rather straightforward. It's right there where it crosses the y-axis. And of course, this corresponds to our ordered pair over here that helps us solve that radical function. So from a graph, all we have to do is read the graph, find the point, the graph crosses the y-axis, and that'll be our solution. There's no need to check it. We could just say x equals 2. Same solution, different method. The thing about graphing is that if it doesn't go through a nice clean point, algebraically will always give us a correct solution. But when it does go through a clean point, like this question, graphing is a much easier method. And we're going to look at more of this as we work our way through this in class.